Okay, so this one, x to the power 4 minus 16. We got two terms. And some students may say, well, this has to be an x squared for this to work. It is an x squared that's been squared. So going back to some exponent rules, right? I'm kind of looking at our square binomial. What is the difference of squares or something like that? So from this, the minus sign is good. But what I have on this is two squared terms, right? So those two squared terms, remember, we're going to put them into two separate binomials with minus and plus. So what's the first term? Well, that would have been x squared. So yeah, I'm going to put an x squared into both of these binomials. And I put minus and plus. It doesn't matter if you put the plus sign in the first binomial. And then 16 would have been a 4 squared. So I've got 4 here and here. Now, this looks pretty good. And we can feel good about what we just did. But it can be factored even more. Not this one, though, because we haven't gone into addition of two perfect squares like this. But this is still a minus of two perfect squares. You got x squared and then 4, which is still a perfect square. So this x minus 4 business, okay, I'm gonna now separate that into two separate binomials again with subtraction and addition. But again, the x squared, that would have just, let's see if I can get enough colors. That would have been an x squared. So I got x as my first term. And then the 4 would have been a 2 squared. So I got an x minus 2 and x plus 2. And then I still have that other binomial, the x squared plus 4.
That just can't be factored out because it's a positive.
That's correct. Now it can be factored out. We just haven't gone that far in how to factor that out yet.
Okay.
But we will. But so yeah, if you're curious on how this works, it's one of those. I may be doing this wrong, so please forgive me if I am. But I believe it's. Yeah, there we go. This, and then of course you still would have had the two original ones.
Boy.
Why?
Yeah, that's an imaginary number, which it's not. It doesn't actually just exist in your imagination. It exists in math, which is great because it gave math people a whole new set of numbers to work with, and then they were like unbelievable. We now get to do more math, and then they didn't, and that's why they did it, and they had to show everyone, and then now you are forced. Well, not now, but eventually you'll be forced to do it probably. And then you'll probably forget about it. Maybe.